Hello everyone, wanted to provide a quick proof of the perpendicular bisector theorem. So what this theorem says is that if you have a segment that has a perpendicular bisector, then from any point on that bisector to the end of the segment that's being bisected in both directions, these lengths are going to be congruent. Right, so I'm trying to prove that CA is congruent to HA. So notice that whenever we construct those segments, we end up with some right triangles. This is going to kind of be the method that I'm going to use to prove that those segments are congruent. So with any proof, the first thing you want to do is start by listing out your given information. So I was given that AT is perpendicular to CH, and also that CT is congruent to TH, that making AT a bisector. Well, the first thing I want to do is I want to use the fact that they're perpendicular to say that they make right angles. That is the definition of perpendicular. It means that the lines form right angles. So I could say that angle CTA and angle HTA are right angles, because that's the definition of perpendicular. And then if I have two right angles, well, all right angles are 90 degrees. So all right angles are congruent which means that I can now say that these angles are congruent to each other. Angle CTA is congruent to angle HTA. Okay, now the next thing I want to do is I want to make the claim that this segment is congruent to itself. So AT is congruent to AT. I can do this because this is what's called the reflexive property. Okay, so if I put that congruency marking in there, then now I see that I can claim that these two triangles are congruent because I've got two sides and an included angle. So I can say that triangle CAT is congruent to triangle HAT because of the side angle side postulate. Well, now that I've got two congruent triangles, I can say that the corresponding parts of congruent triangles are congruent, right? Or we call that CPCTC. I can use this claim to say that that means that CA is going to be congruent to HA. And so this is why we get that perpendicular bisector theorem. I think this is probably one of the quickest proofs, but we had to kind of take a step forward and use triangle congruency in order to get there. There it is.